we picked from WebAssign, and this, I have to move everything to one side to create the function, and the function is continuous because it's a sum of continuous functions. Everything is continuous here. But I have to plug it in carefully in the calculator to find an interval where the function changes sign. So in y equals, let me see if you can see this. Okay. So in y equals, clear whatever you have, and let's plug in 9. Here's e. Please put parentheses. I don't know, it may work without, but I don't want to have to go back. So sine x. Also for sine x, make sure that it's in your mode is in radian mode. Minus x squared plus x minus 1. So I have the function now. Again, click on mode. It's in radian mode. Okay, so go now to graph. I'm sorry, I meant the second and table, of course. Stop. Not bad. To graph, it's okay, because now I see there is a solution between 1 and 2. Nothing wrong with it. So plug in 1, plug in 2, plug in 1, and then plug in 2. That's good enough. So f of 1, you don't need to copy it. It's the number. And f of 2 is less than 0. That's all I needed. So in step number 4, we will say, first of all, here for 2 and 3, by the intermediate value theorem, there exists a c in the open interval 1, 2 such that f of c is 0, and that's what we are trying to find. And now I have to find f prime very carefully, because this is a product of two functions. Leave the 9 alone, waiting outside. E to negative x squared prime is e to negative x squared and multiplied, and parentheses are mandatory, negative 2x times sine x, and then plus e to negative x squared cosine x. And then outside minus 2x and plus 1. I'm going to rewrite it because it's not clear. And now I'm going to distribute negative 18 x. Negative 18x, negative 18x e to negative x squared times sine x plus 9e to negative x squared cosine x minus 2x plus 1. Horrible. But I picked it. I can't blame it on anyone. Okay, so now, it doesn't matter which original value, which initial value you want to pick, either 1 or 2. Just make sure that what you pick will not make the derivative 0. It will not. This is in radians, so it will not be 0. So let's say in step number 5, I pick x0 equals 1. You may pick x0 or x0 equals 2. I may need 4 steps till the method converges. You may need 3. So if the solution is closer to 2, you will finish in 3 steps. If the solution is closer to 1, I will finish in 3 steps, and you may need 4. But it doesn't matter, really. So now we create Newton, which is x minus f of x, 9e to negative x squared, sine x minus x squared plus x minus 1, everything divided by all this, negative 18, x e to negative x squared, sine x plus 9e to negative x squared, cosine x minus 2x and plus 1, they're all in the denominator. So do not delete the function that you already have in the calculator. So just enter with second and insert the x in front, this x, and then minus, and the left parenthesis for the numerator. Go all the way till the end, find the end, put a parenthesis around the second parenthesis, close the parenthesis, and divide parentheses again. Careful with all this, it's ugly. Negative 18 x second and e to the x, in parentheses again, negative x squared, close the parenthesis, come down, sine x, close the parenthesis for sine x, plus 9, again e, how did I pick this? X squared, I'm kidding. Cosine x, close the parenthesis for cosine, minus 2x, minus 2x plus 1, close the parenthesis. Second and quit. Go to y variables. Choose the y variable. Choose a function. You're choosing y1. And in parentheses, you want the calculator to evaluate all this for 1. If you want to start with 2, start with 2. I'll start with 1. So 1 and enter. And I forgot to, please close the parentheses. It's not going to make any difference, but okay, so this is our x1. So the calculator plugged in everywhere in x, plugged in 1, and gave us x1 as 1.373399673. I forgot to look how many decimal digits do they want.
8.
8?
Yes.
Oh my God. Okay. Awesome. Okay, good. So now, all you have to do is just with the previous entry, second and the previous entry, overwrite, replace 1 by the previous answer with second and minus, A and S, second and minus, and close the parenthesis. So now what the calculator will do is, in the function that we plugged in Newton, it's going to plug in everywhere where you see x, it's going to plug in this number. And it will give us automatically the second step, which is the second iteration, 1.339541372. Right now, I don't have to do anything, just second and entry. It will plug in the next one from above. x3, 1.339814665. Did I copy all of them? 9814665. Yes. Again, 2468. Okay. x4, 1.339814681. Okay, fine. And this is it. So this is the answer with 8 digits accuracy. Questions?
How is it that you, why did you decide that the quotient relation is correct?
Because on the fifth one, this is the fifth one, everything is identical. There's no point in going to the fifth one.
Okay.
Now I couldn't stop here because I didn't have 8 digits identical. I only had 7 digits identical till here. But this is 6 and this is 8, so I had to go one more step. But then now I realize that they are the same, so there is no need for number 5. Number 4 gives me everything I need. Is that okay?
Yes.
Good. So from our list, I'm going back. So, okay, I know you have to review more after you finish everything and you have questions, so we also looked at these. So we have about 15 to 20 minutes left, so what would you like to do in 20 minutes? So all these were reviewed. You should be able to finalize your homework. Please review the problems we did in class as well. So, what would you like to continue with? Graphing, very good. So let's do. Let's look at section. That is section. 4.5. So on Thursday, I'll answer all your questions, anything you have for me, and then I would like to make progress and finish chapter 4 with the last section that is part of test 3. I'm sorry, of course, test 4, and start chapter 5. We have 6 sections left. So we have 4.9 and 5.1 through 5.5. Okay. Any preference? There are 8 problems in this section for you to work on.
Maybe number 8.
Number 6, 7, 6, 8. 8.
Mine is
Tangent inverse. Okay, very good. Yeah, we haven't looked at any of those. Very good. So this is number 8. So y equals tangent inverse of x minus 2 over x plus 2. Okay, perfect. It may take, I hope it doesn't take more than 15 minutes, but it may take longer. We'll see. We can stop and finish it up, but we'll see. Okay, so remember a tangent inverse is this graph. So this function does not have, in general, does not have restrictions. However, it's not, this is not x. If this were x, it would have been done by now. But this is not x. So there is a problem with this. And the problem is that x cannot be negative 2. So let's get our table going. So this function, the inner function, exists for anything except negative 2. For any other number, arctangent will exist, but negative 2 is a problem. So then negative infinity, negative 2, 0, of course 2 in a moment you'll see why. So if the function is undefined at negative 2, so will the first and the second derivatives. Okay, so I'm trying to find everything about the function first. I'm trying to fill in this row with anything and everything I can, and then move on to the first and then the second. Okay, so first of all, I know that when I plug in 0, this is negative 1, and arctangent of negative 1 is negative pi over 4. next step is when the numerator is 0, this is 0, this whole thing is 0, arctangent of 0 is 0. Next, I want to determine these. So, limit as x approaches negative infinity from arctangent x minus 2 over x plus 2. So now the question is, where is this going? But we know where this is going. Where is this going? Let's say we don't know. So then I find the limit as x approaches negative infinity from x minus 2 over x plus 2. It's infinity over infinity. Using L'Hopital's rule, I get 1 over 1. So this is 1. So when x approaches negative infinity, this piece approaches 1. Well, arctangent 1 is pi over 4. In the same way for x approaches infinity, this is still approaching 1 and this will still approach pi over 4. Which means y equals pi over 4 horizontal asymptote. Because no matter what, see, we did not use negative infinity, it doesn't matter. The numerator will still be 1 over 1, and the answer will still be 1. Okay, now I would like to see what happens here, and then I'll move on to the first derivative. So let's see a limit as x approaches negative 2 from the left, from arctangent x minus 2 over x plus 2. Okay. So now, where is this going? Let's say we don't know. Let's look on the side. Let's determine this limit on the side. So x approaches negative 2 from the left, from x minus 2 over x plus 2. So obviously the numerator is negative, and the denominator, negative 2 from the left, is still negative. So this is positive infinity. Negative 2.1 plus 2 is negative. Negative over negative is positive infinity. If this approaches positive infinity, look at the graph of arctangent. So when x approaches negative 2 from the left, this approaches infinity. Arctangent of infinity is pi over 2. Okay, let's see the other side. For the other side, limit as x approaches negative 2 from the right, from arctangent x minus 2 over x plus 2. Now this time, this no longer goes to positive infinity. Let's try. It goes to the other side of x minus 2 over x plus 2. The numerator is still negative, but now negative 2 plus is negative 1.9, so this will be positive, so this will be negative. So now, let's see what happens here. When x approaches a negative 2 from the right, this approaches negative infinity, and when x approaches negative infinity, the arctangent approaches negative pi over 2. I should have put those in here. Sorry about that. So this is negative pi over 2. Very interesting problem. That's what I said. It's going to take a while, but it's an interesting problem. Okay, good. We're done with this. Nothing else we can find. Now we're going to find a derivative. And the derivative, we get rid of the arctangent, so that's not bad. So then y prime, arctangent of a function is 1 over 1 plus this squared. But times this prime, which is the quotient rule, with x plus 2 squared in the denominator. The top function prime is 1 times x plus 2 minus the top times the denominator prime, which is 1, but don't forget parentheses because we need to distribute -1. Okay, so messy. Okay, so it's 1 over 1 plus x minus 2 squared over x plus 2 squared times x minus x, that will go away, and 2 plus 2, so this is times 4, over x plus 2 squared. Okay, so then here I will have 1 over, find the least common denominator, x plus 2 squared plus x minus 2 squared over x plus 2 squared, but I'm going to flip it. Let's see, just give me 1 second. When I expand these, I get x squared plus 4x plus 4, and the other one will be x squared minus 4x plus 4. So the denominator will be always positive. Well, we know that anyway. So this is 2x squared plus 8, or 2x squared plus 4. So 4, 2x squared plus 4, and finally 2 over x squared plus 4. I needed this because I have to differentiate again. Okay, so I'm happy. Why am I happy? Because it's always positive, never 0. The function is always increasing. It doesn't give us any headache, no critical no critical numbers, nothing. Always positive. Okay, so now let's see. Keeping my fingers crossed that these two work well together. Let's see. Pi over 4 to pi over 2, yes, that's acceptable. Negative pi over 2 to negative pi over 4, that's acceptable. Yes, that's acceptable, that's acceptable. Okay, now let's see if we find the second derivative. So the second derivative, I'm going to differentiate this. So bring down -2, x squared plus 4 to -2 times 2x. So -4x over x squared plus 4 squared. So I like it because this is always positive, but double prime can be 0 when x is 0. It's positive when x is negative. To the left it will be positive, and to the right will be negative. So it holds water, IP, and it does not hold water. Okay, I think we're fine. I think we can finish it. Okay, I think this is 18. It was 17, yes. Okay, let's give it a shot. Quite an interesting problem. Thank you for picking that. Okay, so horizontal asymptote pi over 4. Pi over 4. It's roughly 1. It's less than 1. Y equals pi over 4. At -2, so if this is 1, oops, this, I'm just gonna say that this, I'm taking different units. So this is 1 and this is kind of 1. Okay, different unit. So at -2, the function has a vertical asymptote. I'm sorry, I jumped. This doesn't. I have something else in there. Sorry. at -2, on one side of -2, there is an open point, -2 pi over 2. So this is double. Pi over 2 will be here. Negative pi over 2 on the other side, it will be here. On the same vertical, of course. So the function holds water increases from pi over 4 to pi over 2. Then it's still opening up, going to 0, 0 where it has an inflection point. It changes concavity. I'm sorry. It's at 0, -pi over 4, right here. I'm trying to finish in 5 minutes. Nobody's fault, but mine. So, -2 is -pi over, let me write that to here, so it's written. So this is -pi over 4. At 0 is -pi over 4. It changes concavity. It crosses it to 0 and going to the horizontal asymptote. Open point, full point, inflection point, opening down and increasing, opening up and increasing to this point. On the same, and this is at -2. Now we can plug it in. Don't forget to plug in pi over 4 in the graphing calculator. We are ready to check. So the second function is pi divided by 4. And the first function is the inverse tangent in parentheses of, it was x minus 2, right? X minus 2 over x plus 2. So x minus 2. I think it needs 2 sets of parentheses. I'm going to put 2 sets of parentheses. X minus 2, close, divided by, in parentheses again, x plus 2, close the parenthesis. And now I need to choose a viewing window. So I don't want to go higher than +2 and not lower than -2 for y, and -5 to 5. So window, -5 to 5 with a scale of 1, and I want -3 to +3. And now I graph. So -5, 5, -3, 3. And I also put y equals pi over 4, and now graph. Here comes this piece. Here comes that piece. It has the inflection point, and here's the horizontal asymptote. I shouldn't even go that far. I don't really need more than -3, 3. But that's okay. So as you see, at this point there is no vertical asymptote as we determined. We calculated everything. So the left hand side, the right hand side. And you can also plug in, but it will give you an undefined. That's the problem here. You can't plug in -2. It will give you an error. So careful with that. So the calculator will not tell you to put the open points, and the calculator doesn't know anything about